Okay, lesson 8.2. We are talking about graphing rational functions. Now, as we talk about graphing rational functions, we're talking about functions that have a fraction involved. Okay? They're all of a similar form today, but it's how to graph these rational functions. Now, I'm also going to throw in the word reciprocal, because these functions are also called reciprocal functions. When you have an x or just an x plus or minus a number in the denominator, that is also a reciprocal function, when it's just some number divided by an x. And so whether we talk rational function, reciprocal function, same idea. Now, a rational function is of the form f of x equals a over x minus h plus k, where x cannot equal h. Now, the x cannot equal h is just because the denominator can never equal 0. And if x and h were the same, you'd have 0, and that's a no-go. Now, as you look at this, we've worked a lot with the letters A, H, and K this year, haven't we? Do those ring some bells? What A, H, and K are going to do to the graph? Does that sound right? Left, right, up, down, vertical stretch or shrink?
That's why there's graphs there.
What does what? Yeah, we're graphing today, right? Yeah. Okay, what does what? What's the K do? That is your up and down, right? The K value, the number added, subtracted at the end, is your up and down. And actually, I'm going to write that up above, actually. So I'm going to call it, I'm going to be official. I'm going to say it's my vertical translation. Now, if you don't like that fancy word of vertical translation, it's your up-down, yes? Feel free to put up-down. Okay, so if the number added subtracted at the end is the up-down, the vertical, what's the H? That's your right-left. The number added subtracted with the x. In this case, in the denominator. Sometimes it's in the absolute value, in the exponent. I'm going to be fancy and say it is my horizontal translation. But again, if you don't like my fancy horizontal translation, left, right. If that speaks better to you, use that. And what's the A?
Stretch.
Your stretch or your shrink.
Shrink.
What if that A is negative? That also means it ends up talking about our, what is it when it's negative? It's a negative due to the graph.
Oh.
Reflect it? Flip it? Okay. So yeah, if it's negative, it's going to be a reflect. So this A value, what I'm going to say about this A value, it can be 3 different things here. It can be a stretch. It can be a shrink. And I'm going to use the fancy word reflect. But if you like Jocelyn's word of flip better, then go for it.
Flip.
Okay?
Makes sense.
Kind of like the left, right, up, down. Go with what speaks to your brain better here. Okay. So that's a lot to write in that little space, but just want to talk about that. All of these today are going to be based on the parent function, y equals 1 over x. So in other words, if you take away the k value, the h value, and the a value, the basic equation we are graphing is 1 over x. That is your reciprocal function. The a, h, and k are just going to do all of our different transformations. So that's what we're graphing, is the parent function, y equals 1 over x. Now, besides graphing, and this more than anything is what makes this lesson a little tedious, we also need to talk about domain, range, and asymptotes. So, a little bit of information, and I'll guide you. Okay, a little bit of information. Domain. What do you guys know about domain when I say domain?
All real numbers.
Could be all real numbers. Depends on the situation. Is domain X or Y values? X.
Not really.
Domain is X. And then range will be Y. So domain is X values. It's how far your graph goes left and right. Okay, anything X value related. Now, our domain today, when we talk about the domain of something like this, it's going to be all real numbers except whatever your H value is. So however far your graph moves left or right, it's going to be all real numbers except that one number, because there's going to be an asymptote there that we'll talk about here in a moment. So domain is going to be all real numbers except X equals H. I'll go through that. Notice on the next line there's a typo. Did you guys catch that?
Yeah.
It says domain again on your paper. What should it say?
Range.
Range. I've already changed mine, so please change yours. The range, well, if domain is left and right or X values, range is up and down or Y values. So the range on these graphs, again, I'll show you here in a moment, is going to be all real numbers except whatever that K value is. So Y equals K. So however far you move your graph up and down, it's going to be all real numbers except that one number. Asymptotes. You guys know what I mean by asymptotes at this point, yes? They're invisible lines that your graph will never cross or touch. It runs alongside that line, right? We graphed some yesterday. We're going to graph them today. But those asymptotes are invisible lines your graph will never cross or touch. And that's what we're going to have today. There's always going to be a vertical asymptote with these at X equals H. So X equals however far left or right you moved. And there's always going to be a horizontal asymptote at Y equals K. So Y equals however far up or down you moved. Now, let's put this all together. Okay, let's look at an example here. Example A. Notice the directions. We need to graph this, and then we also need to identify asymptotes, domain, and range. So I'm kind of squeezing a lot of information in. In order to graph Y equals 9 over X, notice this is a pretty basic equation version of this, isn't it? There's no numbers added or subtracted. So that means this graph does not move left or right. This graph does not move up or down. But it does have a 9. What's that 9 technically do? It's going to stretch it, isn't it? It's going to stretch it by 9, which just means it pulls it away from the x-axis. If you want, we can think of this as 9 over x minus 0 plus 0. Okay, if you want me to try, what I'm doing there is I'm trying to relate it to the version up top. So the idea that this graph is not going to move left or right, it's not going to move up or down. Now, what we need though is we need some basic xy values. And this is like what we were graphing yesterday. Y equals 9 divided by x. Well, if this is 9 divided by x, what can I do with that x? It's 9 divided by x. I can multiply that x to the other side. And the version of this equation I'm going to use is xy equals 9. And this is how I'm going to get some xy points. So if you will, please, an xy chart. Just like yesterday. If x times y equals 9, give me numbers that multiply to be 9. 1 and 9. 3 and 3. 9 and 1. Because in an ordered pair, 1 and 9 and 9 and 1 are different, yes? And so 1 and 9, if I check 2, 2 doesn't work. 3 and 3, if we check 4, 5, 6, 7, 8, next thing that works is 9, right? Now, Just like yesterday, we're going to have 2 quadrants worth. How else do you multiply to be a positive 9? Negative times negative. So we're going to take each of these pairs, -1 and -9. -3 and -3. -9 and -1. So you're always going to have 2 sets of pairs that you can work with here. My graph looks a lot like it did yesterday, guys. Let's graph these points. Okay, 1, 9. Right 1 and up 9. And yes, it is a 10 by 10, so the last number is 10, so just go 1 from the end. 3, 3. Right 3, up 3. 9, 1. Right 9, up 1. Do you remember the curves we were drawing yesterday? They curve out and away from the origin. They're running along the x and y axis, never crossing, never touching. That's what this is doing. So go ahead and work to connect your curve here. My first part of my graph looks like this. And then you have another graph in the opposite quadrant, yes? So -1, -9. Left 1, down 9. Left 3, down 3. Left 9, down 1. So just like yesterday, 2 curves. Because it was a positive 9 we were multiplying to be, my curves are in quadrant 1 and quadrant 3. Okay, now, before I move on, asymptotes, domain, range. In your words, what would you say the asymptotes are? What am I not crossing and not touching? X-axis and y-axis, yes? So, I'm going to try and squeeze information in right here above the next problem. Asymptotes. One asymptote is the y-axis. The other asymptote is the x-axis. However, I'm not going to give you full credit if you just tell me x-axis and y-axis. Math Excel absolutely will not go for just x-axis and y-axis. What's those equations? So, y-axis is a vertical asymptote. Vertical asymptotes are always x equals a number. The y-axis is x equals what number? It's x equals 0. Which should make sense because my graph moved left to right how far? 0. So it's x equals that 0 right there. What about the x-axis? Horizontal asymptotes are y equals a number because it crosses through the y-axis. And if it's the x-axis, that's y equals 0. My graph moved up or down how far? 0.
You're switching like the x and y.
Pretty much, yep. So when you're asked about asymptotes, it's always going to be x equals a number, y equals a number. If your asymptotes are your x and y axis, it's x equals 0, y equals 0. Every time. Okay? Now, we also need to talk about domain and range. Domain. Well, it's my x values, right? Up here it says all real numbers except x equals h. What was my h value here? How far left or right did I move my graph? 0. Or what was my asymptote? It was x equals 0. So when you give your domain, it's always going to be all real numbers except whatever your x asymptote was here. So I'm going to say all reals except x equals 0. Okay. Guess what I'm going to do for range? Range is all reals except y equals k. Range is how far up and down does my graph go? My graph goes infinitely up, infinitely down, except where does my graph not touch?
0.
At y equals 0, right there at that horizontal axis. So my range is going to be all reals except y equals 0. Domain and range will always have that form. So if you can notice the tricks, the connections, the domain and range should not be difficult today. And I try to remember, I want to say it's like multiple choice, but then you have to fill in the x equals or y equals. I can't remember exactly how it works, but. Okay, questions on example A. Okay, shall I try example B? Let's try example B. What do you notice about example B? Okay, same as A. In that it's just 2 over x, isn't it? How far left and right is this graph going to move? It's not going to move left or right, is it? Because there's no number added subtracted x. How far up or down is this graph going to move? It's not, because there's number added and subtracted again. What's that 2 going to tell me? Well, technically it's the stretch, but it's going to help me get my ordered pairs. And here's what I would think, guys. If this is 2 divided by x, multiply the x over to the other side, and basically you're always thinking x times y equals that top number. So what 2 numbers multiply to be, in this case, 2. Okay, so numbers multiply to be 2. 1 and 2. 2 and 1. It's a good thing we know what these graphs look like because we don't have a lot to work with here, do we? Now, I always need 2 sets. If 2 numbers multiply to be a positive, they're either both positives or both negatives. So my other options, -1, -2, -2, -1. Okay, with that in mind, let's graph this. Where's 1, 2? Right 1, up 2. Where's 2, 1? Right 2, up 1. Those are the only 2 dots we get for that piece. What's my graph look like, though? What did the graphs look like yesterday? What did this graph look like? It's curving out and away from the origin, running alongside x and y axis, never crossing, never touching. Does that make sense? So my graph looks like that. There's less of a stretch, and so it's closer to the origin is what's happening. The more of a stretch, so a stretch there of 9, the farther it pulls away from the axis. Yesterday when we graphed that with 48 and -56, they were much farther away from the origin because of that stretch. We just didn't talk about it that way yesterday.
Do we have to extend it all the way?
Like here? Yes, you should. You should not just be doing those two dots because I need to see the shape of the graph running along the axes. If you haven't already graphed this one, do so. -1, -2, left 1, down 2, left 2, down 1. Make sure, though, you're not crossing the axes, are you? Asymptotes. What are my asymptotes?
X equals 0 and y equals 0.
Same as last time? Yeah, same as last time. My graph didn't move any. So my asymptotes, again, if you'd like to think this way, are the y-axis and x-axis, which are x equals 0 and y equals 0. Domain. All reals except, yeah, what's the one x value we're not touching? That 0 right there. Okay, it's always going to be all reals except this asymptote. So all reals except x equals 0. And range. All reals except y equals 0. Okay, range is always all reals except the y asymptote. And the y asymptote is how far we moved up and down. Okay, what is the one value we're not at the level of on the y-axis? And that is 0. Okay, are you feeling better about these? Because we have to change it, we have to switch it up a little bit, right? So this is where I hope I got your confidence going here. Because now we have to switch it up, and did you notice on the next two we are going to be doing some moving, aren't we? So we're going to use the skills we just got here to do the moving. Okay, example C. Y equals 1 over x plus 1 minus 2. Let's talk about movements. Where is this graph moving? Where is this graph moving? What? Okay, left 1. We agree with our left 1? The number with the x, so in this case, in the denominator with the x, tells me how far, left or right, as I've always said all year long, opposite the sign. So an x plus 1 tells me that this graph is going to be moving left 1. The minus 2, it's the number added or subtracted at the end, which tells me up or down with the direction of the sign. So a minus 2 tells me down 2. And I know your problem from above is probably squishing right in there. Sorry. Advantage for me, I changed screens. But now, with that in mind, which way do I want to think this through? So, Normally, my graph is centered at 0, 0, yes? But instead of being centered at 0, 0, my graph is going to move left 1, down 2. So basically, normally my asymptotes are at 0, 0. What I want you to think here is, okay, these asymptotes, I'm going to move left 1. So first of all, I'm going to have an asymptote that is left 1. And I'm going to move down 2. So right here, that point, left 1, down 2, is where my asymptotes are going to cross. And on this graph, you have to draw in the asymptotes because they're not the x and y axis. I guess technically maybe I should have been drawing them in on the last one, but I didn't think that way. So my asymptotes, left 1 I have an asymptote, down 2 I have an asymptote. Does that make sense? Because my graph is moving left 1, down 2. So this is my new centering point that everything goes off of. With that in mind, let's go ahead and talk asymptotes. Except that I can't spell. Although asymptotes is just a hard word to spell. My graph, actually, you probably just wrote that too. Let me start off by saying, let's do the vertical asymptote first. Sorry. Okay. Vertical asymptote first. My vertical asymptote. Where did my graph go? Left 1. So my vertical asymptote, instead of 0, is going to be -1. Now, it's a vertical asymptote. It's crossing through the x-axis. So this is x equals -1. Because it crosses through the x-axis at -1, it's x equals -1. Now let's talk horizontal asymptote, please. Horizontally, where'd my graph go? It went down 2. So my horizontal asymptote, since it went down 2, has to do with -2. Where's that? Where are we crossing through? We're crossing through -2 on the y-axis. So my horizontal asymptote is y equals -2. Vertical will always be an x equal number. Horizontal will always be a y equals number. Now, are we caught up? Sorry. We've dealt with the left-right. We've dealt with the up-down. This is where we need to think about some ordered pairs. And as we think about some ordered pairs, what number do I want these ordered pairs to multiply to be? Why 1? Nah, because it's a vertical asymptote, but it's what's in the numerator, basically. Because what you're basically looking at here is, okay, if you take off the -2, we already dealt with. If you take off the +1, we dealt with. We're looking at y equals 1 over x. So if I'm looking at y equals 1 over x, I need two numbers that multiply to be that top number. So yes, we need two numbers that multiply to be 1. Kind of limits us, doesn't it? But that's all right. I'm going to make this work one way or another for you. Okay, what two numbers multiply to be 1? 1 times 1. Besides +1 times +1, we could also talk about -1 times -1. Now, again, you may not be fans of fractions. I'm going to show you how you can just graph it this way, because here's the deal. Do we know what this graph is supposed to look like? There's two other graphs just like it up above, yes? It's these opposing curves, right? So we use that knowledge along with the point 1, 1 and -1, 1. Now, if you're like, nope, I need more points, Mrs. Sargent. Well, you have to go fractions. 2 times 1/2 equals 1. So if you really wanted another point, you could say 2 comma 1/2 and 1/2 comma 2. You could do that if you want it. Here's what I'm going to do now. Okay, I almost forgot. As we talk about these points here, do you realize how this is working? Am I going 1, 1 from 0, 0? No, I'm going 1, 1 from my new center. Do you understand what I mean there? So my new center is right there where my asymptotes cross. So where my asymptotes cross, from there I'm going to go 1, 1. So I'm technically 1 below the origin there, aren't I? Yeah. My graph runs from that point along the axes. So it runs like such.
Can it touch like the original one? Or can it not touch that one?
Like the x-axis and y-axis? Yes, this crosses the y-axis right here, and it crosses the x-axis. So it does cross and touch those. What it doesn't cross and touch are my dotted lines that I drew in.
So then it can't cross the new.
It can't cross our new asymptotes, right? The old asymptotes don't really exist in this problem.
Okay.
Now, from my new center, we went right 1, up 1, and we also need to go left 1, down 1. So I have an equivalent graph down in what's equivalent to the idea of quadrant 3. Okay, so basically we took these points here, and technically what we did is we translated them, didn't we? We translated them left 1, down 2, if you will. So if you need that thought, we took those points and translated them. My thought is, that's why I graphed the asymptotes first. Because you graph the asymptotes and then you don't even think about translating. You just put them on the new asymptotes. Are you finding a way for this to work one way or the other for you? And we have one more example here to get it kind of sealed up. Now, we talked asymptotes. I never wrote down domain and range. Do you know enough to do domain and range? Domain, all reals except x equals, what was my vertical asymptote? X equals -1. So all reals except x equals -1. Do you see if you know your asymptotes, you can do domain and range, piece of cake? What's my range? All reals except, and don't just tell me -2, though, I'm going to be nitpicky, y equals -2. All reals except y equals -2. Okay. D. And that's where we need to be to finish up today's note. So that's right where I need to be. Where is this graph going? What did I hear? Up 3, right 3. Okay, the +3 right here tells me up 3. Because it's add or subtract the end. So up or down direction of the sign. The -3 with the x is left or right opposite the sign. So that is right 3. Once you've identified that up 3, right 3, what can I go ahead and put on my graph?
Your new graph.
Okay. And we'll do that here in a moment. But we still have to put on our asymptotes. Okay, so asymptotes, I'm going right 3. So that means I need to move right 3 and draw my new asymptote. Can you guys see that asymptote in the purple? I guess I didn't think about the purple may not stand out very well. Make it bigger? Or how about...
Or are you talking about the dot, the actual line?
No, the line.
The line's not right.
It's not bad. I mean...
You're right in front of her.
Huh?
There.
There's my right 3. We also need an asymptote that is up 3, right? So you move up 3 levels. And we have an asymptote here. So that right there, that's my new centering point. I'm no longer talking about 0, 0. We're talking about that. Okay, let me write down my asymptotes for you real quick. What is my vertical asymptote? Where did we go? We went right 3. And a vertical asymptote crosses through which axis? X. So it's x equals 3. Horizontal asymptote. Where'd my horizontal asymptote go? Up 3. Which axis does it cross through? Y. So it's a y equals 3. Okay. What are the pieces of the puzzle that I haven't used?
2.
2 over x, and don't overlook. There's a negative here we got to talk about. That negative is going to flip it. It's going to reflect it. Okay? So basically, instead of being upper right and lower left quadrant, we're going to upper left, lower right. Okay? Now, how I'm going to think this through is y equals negative 2 over x. Or in other words, I need 2 numbers that multiply to be negative 2 is what I'm going to say. What multiplies to be negative 2? And I'm going to, so when we say 1 and 2, the first time through I'm going to say positive 1, negative 2. And when I flip that, I'm going to say positive 2, negative 1. And then I kept both my x's positive this time. A positive x times a negative y multiplies to be negative 2, or negative x, positive y. And so that is negative 1 times 2 and negative 2 times 1. We're going to take these values here, and officially they are translated three right and 3 up. But I like to make it easy on myself. I don't really think about translating them. I just go off of my new asymptotes. So, basically what I'm going to do is from this centering point right here, that's where I'm going, 1, negative 2. So from that point, I'm going to go right 1, down 2, and I'm going to go right 2, down 1. There's a graph. From this centering point, I'm also going to go left 1, up 2, left 2, up 1. And if you haven't already, what else do we need to write down? Domain. All reals except its domain, so it's going to be x equals something. X equals 3. Range. All reals except y equals something, and it was y equals 3. Okay, guys. Sorry, I sped through that last part because I want to make sure and get it down. Homework. It's lesson 8.2 in Math Excel. It should be listed as due tomorrow. Okay? You're going to be answering questions about asymptotes, about domain, about range. You're going to be looking at graphs. So see what you can do with it, okay?